Hello everyone, let's go ahead and take a look at even and odd functions. Now what we're going to do is we're going to take a look at functions that exhibit symmetrical properties when graphed. So for example, even functions are going to be symmetrical about the y-axis when graphed. Odd functions are going to be symmetrical about the origin when graphed. So let's go ahead and take a look at the even functions first. Again, we said that they are symmetrical about the y-axis. So let's say, for example, we have a function y is equal to f of x, and let's say, for example, that that function actually has this point p, which is at 2, 1. Now, being that we know that the function is an even function and it's symmetrical about the y-axis, then we know that this point over here also has to exist on the graph. And that point would be p prime at negative 2, 1. Now let's generalize a bit more, and let's just say, for example, that this is going to be any particular point x, y, and that exists on the function, on the even function. Then what that means then is that the point p prime at negative x, y also has to exist on the graph, because again, we're seeing that it's symmetrical about the y-axis. Now, let's go ahead and take a look at a bit more of an algebraic approach to this. We said that if we go ahead and let y be equal to f of x, and let that function be an even function, then we know by the graph here that this point exists and this point exists on the graph. Therefore, what I can say is that y is going to be generated by f of the opposite of x, right? This y is going to be generated by the f of the opposite of x, and y is also going to be generated by f of x. So if I substitute x into f of x, I get 1. Now, what that means then is if I go ahead and take a look at this, well, the y values are exactly the same, therefore f of the opposite of x is equal to f of x. So this is how we can go ahead now and algebraically show whether a function is even or not. So let's take a look at an example. If I have f of x is equal to x to the fourth minus x squared plus 5, is this function even? Now, the question then, from an algebraic perspective, is f of the opposite of x equal to f of x, okay? If it is even, then this will be true. We're not assuming that it's true at this point, so let's go ahead and question whether that equality actually exists. So if I substitute f of the opposite of x into f of x, I come out with this negative x raised to the fourth power minus a negative x raised to the second power plus 5. Is that equal to x to the fourth minus x squared plus 5? Now, of course, after we do the algebra, we're going to find out that this is indeed true, and therefore what we can say is that f of x is indeed even, and therefore when we graph it, it is going to be symmetrical about the symmetrical about the y-axis. Okay, so let's go ahead and jump now to the odd functions. Now we said odd functions are going to be symmetrical about the origin. Now if we go ahead and take a look at a graphical approach, basically this is what we have. If we have y is equal to f of x, and we know that that function is indeed odd, and it includes this point p at 2, 1, then when we say that it's symmetrical about the origin, the other point which must exist, being that it is symmetrical about the origin, is p prime at negative 2, negative 1. So notice that this is the line that's actually going to help us determine where that other point is going to be that is symmetrical about the origin to p. Now again, let's go ahead and take a look at a more general case. If we go ahead and say that p is going to be x, y, and p prime is going to be the point that is, of course, symmetrical about the origin and also existing on the odd function. So what that means then is if p, x, y exists on the graph, and this graph is symmetrical about the origin, then p prime, which is negative x, negative y, must also exist on the graph. So let's go ahead and talk a little bit more about its algebraic interpretation again. So we say that let y be equal to f of x being an odd function. If that's the case, then this point and that point must exist on the graph. And therefore what we can say is that the f of the opposite of x is actually going to generate this opposite of y value. And, of course, y is also going to be equal to f of x. So now if I go ahead and substitute f of x for y into this equation here, I get the opposite of f of x equals f of the opposite of x. So there we go, there's our algebraic interpretation of what an odd function is. So let's go ahead and again take a look at an example. If our function is x cubed minus 4x, what we want to do is we want to take a look and say, is the opposite of f of x equal to f of the opposite of x? And again, notice that we're questioning this because we're not exactly sure at this point. So if I take the opposite of f of x, which is the opposite of the quantity x cubed minus 4x, and I go ahead and take a look at the f of the opposite of x, notice that what I have is I have equality, therefore I know that the function is odd, and therefore I know that the function, when graphed, is going to exhibit symmetry about the origin. So there you have it. We have even functions and we have odd functions. The geometric interpretation of both of these, as well as the algebraic interpretation of both of these, and how to go about proving whether or not a function, proving algebraically whether or not a function is even or odd, and therefore what those ramifications will be with regards to the graphical representation of the function itself. So the only thing that we haven't really dealt with at this particular point in time is what happens when it's neither. What if it's not odd? What if it's not even? Well, of course, if it's not odd or even, then neither one of these two algebraic equations are going to be equal, and therefore you can eliminate the fact that it is an odd or even function, and therefore we'll have no symmetry either about the y-axis or the origin. But this is the one question that I would like you to go ahead and think about. It's just by inspecting the algebraic representation of the function. So for example, if I take a look at this function here, or if I take a look at this function here, or any function for that matter, how can you determine if f of x is even, odd, or neither? Now, there's very good reason why this is called an even function, and there's very good reason why that's called an odd function. And so we'll see whether or not you can pick up on those clues just again by looking at the equation, and that should be able to tell you very quickly whether or not the function is indeed even, odd, or neither. Okay? So we'll take a look at some of those questions and answer this question in particular in class the next time that we meet. See you next time. Bye-bye.